We have a graph of voltage versus current for two materials. And the question is, which of the two materials has higher resistance? In a previous video, we saw that when the voltage versus current graph of any material is a straight line passing through the origin, then that material obeys Ohm's law. Now, notice that both the materials have the graph of straight line passing through the origin. So both materials obey Ohm's law. So we need to check now which of them has a higher value of resistance. To do this, let's quickly recall what Ohm's law was. Ohm's law says that voltage V equals I, current I, times the resistance R. And to calculate the resistance, we can divide by current on both sides. So if we do that, we'll get V over I equals R. So notice we can calculate the resistance of a material by calculating the ratio of the voltage and the current. So whichever material has a higher value of V over I will have a higher value of resistance. So all we need to do is check which of these two materials has higher values of V over I from the graph. But how do we do that? Because the values are not mentioned in the graph. Well, there are a couple of ways we can do this. One way is we can pick a point on the graph for both these materials such that they have the same value of the current, so that they would have the same denominator, and find out which of them has a higher value of voltage, higher numerator. The one which has the higher numerator will have the higher value of R. So that's one way. Pick same I and check which has more voltage. Another way would be pick points on these graphs such that they have the same value for voltage, so same numerator. Now figure out which of them has a lower value of current, because smaller the denominator, more will be the value of V over I. So you can choose any method and figure out which of them has higher resistance. So it'll be a great idea to pause the video and see if you can, try and do this yourself. All right, I'll pick the one which has the same current. So let me pick some random value of current over here. And let's now pick points on these two graphs where they have this much current. So to do this, we'll just have to draw a vertical line. And now this point on the graph represents this much current, and this point on the graph also represents the same current. So these 2 points now represent the same value of the current. Now all I have to check is which of them has a higher value of voltage. Well, let's see. If you look at this one, notice this has a voltage value which is somewhere over here. And if you look at this one, it has a voltage value which is somewhere over here. Clearly, the first one has a higher voltage compared to the second one for the same current. In other words, the first one has the higher ratio, and so the first one has a higher resistance. So we can say from this, the resistance of the first material must be larger than the resistance of the second material. And if you had picked the same voltage and checked which has less current, you would have gotten the same answer. You can go ahead and pause the video and try that to convince yourself. All right, let's do another one. Again, we have to calculate which of the two has higher resistance. But this time, the voltage is plotted along the horizontal and the current is plotted along the vertical. But that shouldn't confuse us, because the steps are still the same. So pause the video, use the same steps, and see if you can get the answer. All right. Again, I will pick a point where the current is the same. So let's take let's say, let's assume the current is somewhere over here. Now let's pick point on these two graphs where the current is the same. So if I do horizontal, this time I have to draw a line horizontally like this. Well, since this line doesn't meet over here, let's pick a point somewhere down. Okay, right. So now we have this point and this point. Both the points correspond to the same value of current, this much value of current. And again, I have to check which of them has a higher value of voltage. So let's see. If we drop a vertical line, the voltage for the first one is somewhere over here. The voltage for the second one is somewhere over here. Clearly, we can see the second one now has a higher value of voltage. This is a higher value of voltage compared to the first one. And so the second one has more voltage compared to the first one for the same current. And as a result, this time it's this one that has a higher resistance. And so R2, this one, has a higher resistance compared to R1. So regardless of which axis is voltage and which axis is current, if we pick a point where the current value is the same for both the graphs and figure out where the voltage is more, we can easily find where which of them has a higher resistance.